the lab, we're going to do the density of 10 different objects. So fundamentally, density is mass divided by volume. And in this lab, we're going to use a triple beam balance to determine the mass. And a triple beam balance, like any other instrument, to read it correctly, you read to the smallest division, and then you're going to approximate between the lines. So if we have a triple beam, we're going to look at it here. These are grams. So we're going to read, so this is a gram. That's a tenth of a gram. If we approximate between the lines, that's going to be a hundredth of a gram. So when I'm looking at your lab and I'm looking at your measurements in grams here, every value should be to a hundredth of a gram. If something was exactly 50 grams, am I going to write 50? No, I'm going to write 50.00 grams. That is the correct way to measure, again, using any instrument. Now, density is mass divided by volume, but how we calculate the volume is going to be different depending upon the object that we have. So we have a bunch of objects. So I have a lot of things like this. They're like rectangles or blocks. Okay, there's quite a few different ones. So for these, if you look at the front, and on the front I have nice directions, it tells you that you would just, or maybe I didn't do it, here you would do length times width times height. So if I'm measuring the edge of one of these and I'm using my meter stick and I'm measuring in centimeters, a centimeter times a centimeter times a centimeter is a centimeter cubed. So I would write the appropriate unit here. Now I have some objects like this. That's a fun noodle. I don't know why people poked holes in it. And then I have other objects like this. Now, for these two, what we're going to do is these are right cylinders. So we're going to use the equation for a right cylinder. Volume is equal to pi r squared, which is the area of a circle, times the height. So that gives us the volume of the cylinder. Now, even though this one is a right cylinder, we'll also calculate with this one. So we have 3, we're going to use that equation. Now this one is a right cylinder, but it's hollow. Okay? We could do the inside and outside diameter, but since we're not using sophisticated things like a vernier caliper today, we'll just, with this pipe only, what we'll do is we'll use the same method we're going to use for the rock. So when we have something unusual like this, we will use the water displacement method using the graduated cylinder. So I'll fill my graduated cylinder up to a certain height. I'll drop the rock in, and then the difference would be the volume of the rock. And I'll do the same thing for the pipe, because the pipe can easily fit in here. What we are not going to do, is we are not going to put this in here, because when we do, it just barely fits. When the water's in there, we're not going to be able to get it out. And please don't test me to see, oh, I want to see if these properties of water actually exist, because it'll be very difficult to get this out. So do not put this in there. All right, so here for description, we're going to write the object. I don't care how you describe it. So you could say clear, rectangle, yellow, wood block. This is actually countertop Mr. Forrest cut up for me. Red fun noodle. These, I don't know, I found these in the garbage somewhere and I thought, oh, those will be neat for density, so I don't even know what this is. So you describe it any way you want. Mass, volume, and then density with the units. Now, when in this class, whenever you do a lab, you have to answer the questions in complete sentences. You don't just put one word. So if you were given the density, so you're going to describe here. Every time we do a lab, I don't need to see 10 times you calculating density. I need a sample calculation. So for example, to show a sample calculation of volume for the fun noodle, so what does that mean? So for the fun noodle, I would first write the volume is equal to pi r squared h, because the fun noodle was a right cylinder. I would substitute in my values, and then I would write my final answer with units, and I would put a box around it. Then I said pick any object on the table, show the sample, the density. So whenever we do a problem, we write what we're given. So we're given the mass, whatever in grams. We're given the volume. We want to find the density. We write our basic equation. Density is mass over volume. So then we substitute in our values. And then we solve for what we want to solve. And that's what's called showing all your work. That's what you'll be required to do on tests on FRQs. Write your given and find, rearrange and solve, substitute and solve. Remember, when we do a lab, it's all about getting the data. So when we do this lab, is one person going to go back to the lab table and everyone's going to sit there like, hey, what are you doing this weekend? Or are you just and wait for them to mass everything and measure? No. There's lots of things to do. So one person can mass all the objects. Somebody else can use the ruler. Somebody else can use the graduated cylinder. Somebody else can start doing calculations. Okay? Everybody should have a task, because remember, that's called working efficiently and effectively in a lab group.